Hi, my name is Jonas and I welcome you to this video on best practices for implementing the sequencer in EEROS. Before we can start with the actual implementation of the sequencer, we need to sketch our program on paper. Doing this, we should think about the following questions. What tasks should the robot perform? How can we arrange them into steps and sequences? Which sequences need to be blocking and which can run in parallel? If they run in parallel, when do we wait for the other sequences to finish? Which conditions do we want to monitor? Do we need exception sequences to handle certain conditions? Let's consider an example. Suppose we want our mobile robot to move in a square with 1 meter side length. Further, we want the robot to wait 1 second at each corner before it moves to the next one. Therefore, we need 2 steps, one to move the robot to a desired location and the other one to wait for 1 second. We can arrange both in the main sequence and duplicate them to complete the square. So we do not need any additional sequences and we also do not need to think about whether they should run in parallel or not. However, it might be that the path to the next corner is blocked. We can monitor if the path is blocked and trigger an exception sequence if it is. In this exception sequence, we then inform the user and wait until the path is clear. Once the exception is over, we resume to the main sequence. We will now look at how we can implement this. First, we will talk about how we can implement a custom step. The template project provides a template specifically for this purpose. We can simply copy the file and rename it the include guard, the class, and the constructor. It is best to use a descriptive name. Next, we define all the necessary variables, conditions, monitors, and exception sequences under the private specifier. And finally, we implement the action method. It is possible to add parameters by overloading the operator method. We can store the parameters to use them in our other methods, and at the end we must return the start method to start the step. We can also check for a pre or exit condition by overriding the respective method. If the check precondition returns false, the step will be omitted. On the other hand, the sequencer will remain inside the step until the check exit condition returns true. Therefore, we can use the check exit condition if we want to wait for a certain event, and we should never use a while loop to wait for something. But let's use the move to step from our previous example to see how we can implement such a step. First, we obviously copy the template and rename the file, the include guard, the class, and the constructor. After that, we define the necessary variables under the private specifier. We need a reference to the control system since we want to control the robot's movement by setting the target of the path planner that is running in the control system. Further, we define a variable to store the current target position. We then initialize them in the constructor. After that, we overload the operator method. This allows us to pass the target position when we call the step. Next, we implement the action method. In there, we simply set the new target for the path planner, which is running in our control system. Then, we also need to define the exit condition, since we want to stay inside the step until the target is reached. Finally, we can also implement the check precondition method. We only start the step if we are not already at the target position. The process of defining a custom sequence or a custom exception sequence is very similar to defining a custom step. There are only 3 differences. First, there is a different template available in the template project. Second, we need to specify whether the sequence is blocking or non-blocking. Setting the last parameter in the initializer list to true makes the sequence blocking, while setting it to false makes it non-blocking. Blocking sequences run sequentially, while non-blocking sequences run in parallel. Third, we can use steps or subsequences inside a sequence. The rest remains the same. We still need to implement the action method, and we can overload the operator or define pre- and exit conditions. Now we know how we can define our own custom steps, sequences, and exception sequences. But what about conditions and monitors? Well, conditions are best to be defined in the same header file as the sequence or step in which they are needed. We will directly use the previous example to understand how we can implement a new condition. In the example, we had a condition that checked whether the path is blocked, and if it is the case, it triggered an exception sequence. Since this condition will be used in the main sequence, we implement it directly in the main sequence header file. To create our condition, we create a new class which inherits from the EEROS Sequencer condition. Since our condition should check whether the path is blocked, we call it checkPath. Suppose we check the path with a LiDAR which is running in the control system. To know if the path is blocked, we can call a function from the LiDAR class. Therefore, we once more need access to the control system, which we can get by storing a reference. All that is left to do is to implement the validate method. It should return true if the path is blocked. Now that we have our condition, we can define it inside the main sequence under the private specifier. Further, we need a monitor which periodically checks the condition and triggers the exception sequence if the path is blocked. The monitor is already fully implemented in EEROS. Therefore, we can directly define it under the private specifier. And finally, we also need the exception sequence, which we won't look at in detail in this video. However, we have seen before how we can implement it. All that remains is to initialize the condition, monitor and exception sequence and add the monitor to the main sequence. All of this is done in the constructor of the main sequence. We first call the constructor of the condition and give it a reference to the control system. Next, we initialize the monitor. We need to give it a name, a reference to the caller, our condition, what to do after the exception, and the exception sequence. Then, we also call the constructor of our exception sequence. And finally, we add the monitor to the main sequence. And like this, we have successfully implemented the condition, monitor, and exception sequence. Thank you for following me through this implementation guideline, and I will see you in the next one.